In this section, we focus our attention towards tangents, areas, arc length and surface area when the curve is represented in a parametric format. So, first we will discuss about the tangents. And for the tangents, we basically need to know how to differentiate when a curve is given in its parametric format. For example, let's take this one. Let's say if x is described as t squared, remember this is the way that we represent x and y coordinates in the parametric format. So let's say if x and y are described like this, then how now that means there will be a certain curve originated from this x and y coordinates. So if we have the coordinate system as x and y, then for this relationship there will be a certain curve. We don't know the exact shape, but let's name this as C, right? So this is the this is the relationship between x and y which we obtained from plotting this graph, right? And I explained all the basics of this parametric formats in the previous video, so I highly recommend you to go over that video before entering to this differentiation part. Okay, right? So now suppose we need to get the derivative of this curve, right? So that is basically what if we need to find dy by dx in this curve, right? Because now say if they have given a direct relationship between x and y, then from this equation we can directly compute dy by dx, right? But here both x and y are represented with the help of a third variable, right? So what we can do is, now first of all we should visualize x as a function of t and y also as a function of t, right? So now both x and y depends on t, right? That means we can differentiate x with respect to t, right? We can differentiate x with respect to t and y also with respect to t, right? Now in order for this term to make sense, x should be a variable that depends on t, right? Now say if we have this sort of a relationship, then there is no point of differentiating this equation with respect to a totally different variable like a, right? Because there is no mentioning of a in this equation, right? So in order for this differentiation to make sense, there should be some sort of a dependence, right? Now here we can clearly see that x depends on t, so dx by dt makes sense, right? Similar thing goes for the y variable as well. And then we can use the chain rule to compute dy by dx, right? So this is our goal, and we have now in calculus 1 we did a thing called chain rule, and that goes like this, right? So a very easy way for you to remember this chain rule is to consider this sort of a cancellation. Say this is kind of a division, then we can cancel these two terms, so only dy by dx will remain. But be careful, these are not divisions, so this sort of a cancellation is not valid. But just to remember this formula, you can consider this sort of a cancellation, so that the original term will remain, right? But anyway, this theorem holds true. Although this is not a cancellation, we can prove from the tools in mathematics that this relationship is true. Okay, so we can directly use this relationship in order to obtain dy by dx where necessary, right? Now this is a point where we can easily use the chain rule in order to compute dy by dx. Say if we have that example, which is x is equal to t squared and y is equal to t cube minus 3t, then from this equation we can separately compute dx by dt, right? And that will be equal to 2t, right? And dy by dt will be equal to 3t squared minus 3. Therefore, from the chain rule, it says dy by dx will be equal to dy by dt, that is this one, 3t squared minus 3 times dt by dx. Now, be careful. Now, this is dx by dt, right? But here we need dt by dx, right? That's kind of the opposite of this one. Now for that also we have another rule that's also basically the chain rule, right? We can write dx by dt, or let's say dt by dx, it works both ways, this one as the reciprocal of dx by dt. So this is also a similar kind of a chain rule that we can use, right? So for this portion we can have the reciprocal of dx by dt. Now you must remember these two formulas when you are dealing with parametric equations, because this is a very nice tool that you can use to compute the derivative of y with respect to x. The main reason for using all these rules is because now in order this plot itself takes the relationship between x and y, right? But the thing is, the x is represented separately with the help of another variable of this third variable, and y is expressed separately. There is no direct relationship between x and y, because if there was such a relationship, we can directly compute this dy by dx term, right? So this is how we should compute the derivatives when x and y are represented with the help of a third variable. So basically what you should do is you have to remember these two formulas which you have done in calculus 1, right? So with the help of these two we can easily identify the derivative of y with respect to x. And in the next video we will go over some a problem which involves these derivatives.